Hi everyone, welcome back to the workshop, and it's repair time again. And I've got a HP 3457A 6.5 digit multimeter. Now yes, if you've been following my channel you may say, Ian, you've already got one of those. I do actually, but I couldn't resist picking this one up. Sold as faulty, so we're going to take a look at it and see if we can't get it working. Let's take a look. So I arrived in the workshop today and I just couldn't resist unboxing it and getting started on it. Now if you take a look at the front of it, I don't know if the camera can pick that up, but it's got a pink or a red hue across the front of it. I don't know if that's some sort of spillage, yeah, around the banana sockets there. It's all got this sort of red hue to it. I don't know what's going on there. Bit of damage on the banana sockets there as well. They've lost the front. It's obviously been bashed down on something like that at some point in its life. That's normally how these get broken. Other than that, it does look to be intact anyway. There's some seals on the sides and the back. They're all broken, so certainly someone's been inside it before. And if we take a look at the back, it does look to be intact. It's got the HBIB, the GPIB functionality on it, so I can extend the range of it to 7.5 digits, which you can do with this unit here. That's it right round to the front again. Now I do actually have some spares for the HP 3457A based on my original 3457A that I repaired some time ago and put the LED backlighting on the LCD, which I'll link down below. So I do actually have a spare front panel here, and luckily enough the bananas are all intact there, so I might transpose this panel onto there. We'll see how it goes. This one here is a bit chewed up in some of the rubber buttons there, but the one on the unit I've just got looks to be intact. You know, got the board in the back there, and I also actually have a spare LCD, so I've got one or two spares. So let's open it up, see what it's like inside. I've got no idea. It was never powered up for the ad where I bought it from, so there could be anything wrong inside it. So let's take a look. Right, here we go. So I haven't been inside it, like I said, and yeah, some of these seals in the bottom here have definitely been broken. So, I mean, it is an old instrument, so the chances of someone having been inside it sometime in the past are quite high. If I remember rightly, this thing's a pain to put back together again. But we'll see how it goes. Looks like it's a pain to take apart. Here we go. So that's the lid off, and it does look like it's in not bad condition inside. At least the shield here looks to be intact. It's there, it's not missing, as are everything else. So we'll just take it apart a little bit further, get rid of these shields and get down to the circuit boards, and we'll have a look. Now, looking at some of these crosshead screws here, they're in a little bit of a state. Those two are okay, but this one here has been knurled to death, and that one there's got a little bit of corrosion on it, but we'll take a look at that, see if we can get inside it. And the main board there looks to be in very good condition. Yeah, no corrosion or anything. No water damage. Looking good. Okay, a little bit of a tour before we go any further. There's 4 boards basically in this unit here. You've got the main digital section here. This is a microprocessor on this side here, and you've got the main analog board at the bottom there, a great big board at the bottom there, which interfaces obviously to the front panel bananas, all the relays for switching the various modes. You've got a voltage reference here and a little daughter board there. This is an LM399 with an HP part number on it, I believe. And you've got another daughter board here. This is the AC board for the RMS, AC RMS conversion, and that's the 4 boards. The digital board only has a serial interface between it and the main analog board there. There is an extra microcontroller on the analog section, an 8051 or an 80C51 I think it is, a CMOS version. so that the UART here can communicate with the main analog board via this little ribbon here. There's a couple of opto-isolators down on here, two different part numbers, so I'm presuming that one goes one way and the other one goes the other way. And this UART is a 6402. I know that chip quite well from back in the day. That's a serial UART, one channel, obviously for the comms. So you've got the mains transformer here, the secondaries come off of that down onto the main digital board to power it, and you've got another separate bunch of secondaries that come across here onto the main analog board. So that's how the analog section is isolated from the digital section. And everything looks to be intact there. I don't see anything missing, nothing's been cut, nothing's been broken off. Everything just looks nicely in place, but how well it works I don't know. The caps don't look too bad, they're certainly not bulging anywhere. So I think the first thing we'll do is we'll check out the transformer, we'll make sure that's intact, because I believe that's a failure point for these units here, is the transformer. I've been waiting for a transformer to fail at some point during my restoration or repairs of test instruments, because I'd love to rewind one of these, because I used to do that years ago, but we'll see how we get on with this. So let me get set up here and we can check out the transformer. Right, that's me all set up, ready to go. So first thing I've done is on the back of the unit there's the input voltage line selector there, so I've set that up for 240 volts because I am in the UK. And we'll just go across the two pins on the connector there. Nothing there. Ah, wait a minute. Power switch. That's on. Ah, I'm still getting nothing. I'm not getting a primary winding there. Wow. I wonder if there's a fuse missing. Let's take a look at that. This is an old anti-surge fuse. So let me just check that. That fuse is blown. Right, okay. Right, so what size is this? BUSS MDL 2/10. That's a 200 milliamp fuse. Wow. I don't know if I've got anything like that in stock. Let's have a look. Well, that's not great. The input fuse is blown. I don't know if I've got anything small enough. 500 milliamp, that might do it a push. Quick blow though. Yeah, these are all quick blow. Oh, that's a slow blow. What size is that? 1 amp. No use, no use. I think 500 milliamps is probably as smallest I've got actually. So I think we'll go with that. It's a quick blow, 500 milliamps. So we'll just go with that. Right, that's a fuse in, so let's go back to start again. So the power switch is on. I'm still getting nothing. So just in case it's a filter, I shall go down onto the connector. First of all, I'll check out the fuse holder, make sure it's not open. Well, it's not exactly dead short, but it's definitely not open. And we'll go down on to the primary winding of the transformer, which I think is these two here. Nah, still nothing. Okay, so what I'm going to do is I'm going to put the line selector to 120 volts. There's two switches on the back of the unit here for selecting it, and you move one of them to the 120 volt position. And whilst I was looking at the back here, actually it does actually say 200 milliamp fuse for 100 to 120 VAC AC operation. If you want 240 volt, it's an 80 milliamp fuse. I definitely don't have that, so we're going to have to go with the 500 for the time being. But I've set it to 120 volt line voltage on the back, and now the power switch is on. And then now if we go across the filter, the input connections, I'm getting 2 ohms. Wow. So let me go back to the 240 volt position again. There. Measure it. Nothing. And it does actually have a 220 volt position. So let me just select that now. And that's nothing either. So there's the 2 switches there, and it's clearly marked. If you want 240 volts, that one's in that position there, and then that position there, and there's your 240 volt selection. So that's what I was doing, and then if I put this one to this position, I get 220 volts, and that's 100 volts, and that's 120 volts. And it looks like the 220 and the 240 volt selection isn't working. Wow, that's not good news for me. So that's the main on-off switch on the front panel. It's actuated by the front panel push button, and there's the line selection switches there. And then you've got the multiple primaries on the transformer itself in order to make that selection. So there's either an open circuit on one of those switches, or the tracks in the PCB or something like that, with the soldered connections on the switch onto the PCBs maybe broken, something like that, or the switch itself's duff. Of course, the other thing it could be is the transformer itself. Now I've just checked my good 3457A offline, and I should be getting about 184 ohms in the 240 volt mode there. So we've either got some faulty switches on the back for the line selection, or my transformer's gone. Right, so what I'm going to do to test out the primaries on the transformer, in case it's not the switches on the selection switches on the board, I'm going to actually measure the primaries on the connector here. This connector here has got some black wires etc. coming off of there, and that goes into the transformer. Those are the primaries there. And if I look at the diagram, you can see this is the connector here, and you can see 5 wires going into the transformer. That's for the primaries. You've got a single coil there, and you've got another one there with a center tap there. So I should manage to locate that on the connector and measure it virtually almost onto the transformer itself. Those primaries should be intact. So it's an 8-way connector, and we've got pin 1 at the top. You've got pins 2 and 3 according to the diagram are the input AC, and yes, that's right there. You've got these 2 white grey wires there. One goes up onto the mains filter, and the other one goes to the fuse holder at the back. So yep, that's definitely the incoming mains there, and that one's there. So that's 1, 2 and 3. So that's 2 and 3 there. So the first coil I'm going to look at is again across 7 and 8. So it's 1, 2, 3, 4, 5, 6, 7 and 8. That's the last 2 pins there, and that 8 pin there. Let's try and get a better connection. Nothing. Well, straight off the bat I'm getting nothing on 7 and 8. Wow. Okay, let me try 4 and 6. So that's 6 and that's 4. I get something there. 0.8 basically of an ohm. So that's 4 and 6. So what I'm doing there is I'm across 4 and 6 here. So that's across here. So I should get a slightly less resistance across 4 and 5, and also 5 and 6 there because of the center tap. So yep, so that's 0.8. So that was across 4 and 6. I'll go across 4 and 5. Yep, 0.3. And if I go across 5 and 6, I'll get something similar, I would have thought. 0.7. Okay, so it's not a centre tap, it's way off. There's more turns on one side of that centre tap than there is on the other. So that's across the two outside again. Yeah, not much at all. It's probably being used for the difference between 100 volts and 120, was it? And also the 240 and the 220. It's just that slight extra number of turns to allow for 240 and 120 usage there. But this is the one that's not working there. That's the problem one. Definitely. Yeah, it's basically open circuit there. Okay. It's a little bit out of sight for you to see, but somebody's definitely had the soldering iron in there, because the back of the fuse holder on one side only that goes to that connector made a bit of a mess resoldering that wire back on there that goes to pin 3 of the connector there with the AC input. So somebody's made a bit of a mess there. But it's looking like I've got a knackered transformer. So that's a transformer just about out. So this is the wire here. You can see the state of that. That was onto the fuse holder at the back there. So somebody had definitely been taking that off and on and sometime in the past. And also, if you look over here, these BNC connectors here on the back panel, they go off to the same connector. It's a shared connector with one of the primary connectors down on the main board. They've been desoldered as well. So somebody has had this transformer out of the unit in the past. But just got to desolder it myself, and we'll take it down onto the workbench and we can see if we can find out what's wrong with this transformer. So let's try this again now that I've got it completely isolated here. 7 and 8 down here, that was the side I was getting nothing on. Yep, I'm getting nothing there at all. Open circuit. Now, this is the external side here. It's got this little can in the back to protect it. Look at this here. This is in pretty bad shape, such that you can actually see, if I can zoom in, you can actually see the windings there. There's one there, you can just see the top of the windings there. So this is the primary side here, and that's the secondary side there. You can tell that because on the secondary side there's the secondary windings there, and then the primary side here. So I suspect that looks like it's been heating up and it's burnt, so that's not looking good. So, but I think what we'll do is I can pick away. So that the two wires in question are this two here that go up through the same channel together. All the other primaries go up on the other ones there, but this two here is the 7 and 8 for that primary winding there. So I think I'll pick away at the tape. I wonder if someone's been picking away at that already. Nah. So I'll pick away at that and see if I can expose where these wires are attached to the windings itself, just in case we're lucky and it's a break right on the surface there. Okay, so you have to be extremely careful when picking away at this. Now, of course, I'm assuming the crimp's okay on those two wires there, but yeah, they do look to be intact. So you have to be extremely careful picking away at this here. You don't want to cut through the windings there. So I'm just trying to pick away with the blade pointing up the way. Wasn't too bad to get to. So here's this top one here. You can see it come away along there. It loops back and it's tinned, and buried in there somewhere is the other end of that wire there. So let me dig a little bit and see if I can find it. Oh, this is not good. this is one of the ends, and as you can see, I don't know if you can see that. Let me just get a bit of paper in here. You can see here is the winding broken. Soldered onto the wire okay, but then this distance back and it's broken, and unfortunately that's down inside here somewhere, so I'm just trying to locate it. Don't build up much hope for this transformer, because I mean it does look like it's been heating up. I think it's pulling back this here, it looks a bit scorched here, so it looks like it's been burnt, so overheating certainly on the primary side there. So it's not looking good. Okay, I made the decision that I'm going to disassemble this transformer. I'm going to take the E and I plates completely off. I'm going to get the bobbin out. I'm going to unwind it, cut out all the old primary side windings. I think I'll leave the secondary side because it does appear to be intact, and I'm going to rewind myself the primary side. Oh, that's what I thought I was going to do. So as you can see, I started taking the transformer apart. This is the cover that goes around the edge, which just hides the laminations there, and I started picking apart the plates. Managed to get two of the eyes out. They were really pretty easy because they were just in here. It wasn't a problem to get them out, and I noticed when I took them out they're covered in some residue. It looks like some remains of some varnish or something like that, and unfortunately that's stopping me from completely disassembling all the plates. I should be able to pull the E and I's out from the bobbin. Unfortunately they appear just to be stuck together. I mean, I can prise them apart, as you can see there. I can run a knife right round the edges there and break any of the glue or residue from the varnish that was sticking them together. However, I can't obviously get right inside where the middle part of the E goes through the centre of the bobbin, and unfortunately that's stopping me from pulling out the E's completely. I mean, I've tried everything. I've tried knocking it. I can get it to wiggle slightly, but that centre part is just stuck, fast. So I haven't got much choice but to chuck away this transformer. So what I'm going to do is, and there's going to be a part 2 to this video, what I've decided to do, I've purchased a couple of transformers that have the same mounting centres for here, and here, 40 VA transformer, and I'm going to hopefully take that one apart when it comes. I've tried to buy some transformer kits. That used to be what you could buy back in the day. I've got a couple of kits here, as you can see. However, these are no longer available, and I can't find anything like it anywhere else. There's a 100 VA one old stock on eBay right now, but I think the 50 VA one's probably too big and the 20 VA one's too small anyway, so I'm kind of really stuck, and I've hunted high and low. I've got a contact that winds toroidal transformers, and he was telling me that yeah, nobody seems to make them anymore. So the plan is to hunt around for a suitable transformer that I can actually disassemble. I might hit it lucky. Some transformers are actually welded along here on both sides just to secure it, because it's not relying on the bolts to hold the plates together. So hopefully I can find one that doesn't have that, and I'll come back in a part 2 and we'll see if we can't get this up and running. Thanks for watching.